Okay, in that last video we talked about what is the Pythagorean theorem and its converse, why does it work, and now we're going to apply all of that stuff. So typically when you're applying Pythagorean theorem, you want to double check that you're working with a right triangle, and each of these triangles is a right triangle. You also need at least 2 side lengths in order to figure out the last one. Okay, well, I've got 2 sides, I'm missing one. Same story, and same story. So there isn't a variable here. I'll go ahead and use one. How about z? And then over here I'll use w. So the one thing that students typically kind of mix up with Pythagorean theorem, they usually put the variable on the wrong side of the equation. For example, a lot of times with this first one, I'll get students who will write 3 squared plus 6 squared equals z squared. Okay, so this is not correct. It's not correct because the hypotenuse is the length that should always be on its own in this equation. So the correct equation should be something like 3 squared plus z squared equals 6 squared. Because 6 is your hypotenuse, so that should be on its own. That's going to give you a totally different solution if you don't have the right equation. Another big suggestion, know your squares. I know I've said this before, but you will want to drill yourself on the squares from 1 all the way up to 20. So you'll want to know what like 14 squared is, and what 7 squared is, and what 17 squared is, and what 16 squared is. You'll want to know all of those squares sooner rather than later. If you don't know them, it's going to make this chapter, and actually the rest of the year, really difficult. So make sure you drill yourself on those. Alright, so let's go back to this one. That's a 9, so z squared is 36 minus 9, which is a 27. And now we go ahead and take square roots. Just like we had in that algebra review after your tests, those of you who have taken it, we are going to now reduce all of our radicals. We're never going to leave them in unreduced form, meaning we want to identify if we have any perfect square factors. Well, 9 is a factor of 27. 9 is a perfect square. So just as a review, you could write that as the square root of 9 times 3, which is the same as the square root of 9 times the square root of 3. And any square roots we know, we're going to go ahead and take. So that would be our final answer. My pencil looks like it's just about had it. Is going to be 3 square root of 3. So we want to leave our answers all like this from here on out. So like, even though this is going to be really common in this chapter, in chapter 9 or 10 or whatever, if you come across a problem with a radical, you're going to have to reduce that radical. And it says at the top of every test and quiz that I've given everyone, and it will continue to say, leave all answers in reduced fractions and or radical form. So this would be reduced radical form. This one here in the middle, that's 6y and 10. So that should be 36 plus y squared equals 100. Again, be really careful to put your variable in the right spot. If you subtract 36 and then you square root, you'll get the square root of 64, which is an 8. Alright, so y should equal 8 for this middle triangle. Over here, oh, this is a really big one. 49, which is 7 squared, plus w squared equals 25 squared. I want to say that that's 625. When you subtract on both sides and take the square root, if you were to type this into your calculator, as long as you type it in correctly, you're going to get a 24. How do I know that? No, I didn't do all that in my head. 7, 24, 25 is another Pythagorean triple to know. along with 3, 4, 5, 5, 12, 13. There are a bunch of them. Oh, 5, 12, 13. That looks a whole lot like this one right here. X equals 13. Okay, you might be going, cool. So that means I don't have to show any work on any tests or quizzes, right? No. You still have to show work. However, if you know these Pythagorean triples, I am totally okay with you telling me you know those Pythagorean triples. So like if this right here was a test question, go ahead and write x equals 13. But then next to it say 5, 12, 13. Now I will caution you, if this isn't a 5, 12, 13, and you write this answer and you still put 5, 12, 13, you're not going to get credit. Make sure, if you want to take those shortcuts, you first off know those shortcuts and you know where to use them. So like if you said w equals 12, because 5, 12, 13, sorry, that does not apply because this is not a 5, 12, 13 right triangle. Likewise, if you did notice that this one's a 3, 4, 5, that's 3 times 2, 5 times 2, so this will have to be 4 times 2. You could have just said y equals 8, in parentheses, 3, 4, 5. I would be totally cool with that, because that tells me you know more than you need to know. You know the shortcuts, and you also know how to use them in the right place. Things can get a little bit more complicated, like this next one here. So we've got variables on every part, but we do know that it's a right triangle because they put that right angle box, which means we can still use Pythagorean theorem. So this is like my A and my B and my C. So I've got to square this one, and then I have to square this next one, and I have to square the last one. Alright, a lot of you will be really tempted to say, ooh, square root, that kills the squares. Okay, that is an illegal math move. That'll put you in math jail. So just as a reminder, the square root of a plus b is not equal to the square root of a plus the square root of b. In other words, you cannot split square roots or cube roots or any kind of radicals over addition or subtraction for that matter. You can do that for multiplication, but you cannot do it for addition or subtraction. You can also do it for division. That is okay. Addition and subtraction, not okay. So we can't just take square roots and eliminate everything. We have to FOIL. So like we have to do x minus 5 times itself, and x plus 2 times itself, and finally x plus 3 times itself. Also keep in mind, guess and check is not really a valid method. I don't really ever let anyone do guess and check on tests or quizzes. You might be wondering, well, what if I guess the right answer? Alright, well that's luck. I am not a luck teacher. I don't teach people luck. I'm trying to teach you all really good methodology. I'm trying to teach you all a really good way to approach problem solving. If you can guess the right answer, that's good, that's great. However, I need to assess not your guessing techniques, but how you all can interpret the different things we talk about in class and how you can apply it. Essentially what this comes down to is you are learning basically a different kind of a language. I know technically it's not a language on its own, but this use of symbols and this chain of reasoning is very similar to written language. So that's something that I have to grade on. It's not a personal thing, that's just as a professional what I've got to do. Anyways, going back and foiling these, this is going to be x squared minus 10x plus 25. And then when you FOIL this expression here, you're going to get another x squared and a 4x and a 4. And then on the right side, x squared and 6x plus 9. If you're feeling really shaky on foiling, I highly suggest look up on YouTube, which you're already watching, videos on how to practice foiling. This is something you all should be really comfortable with in an honors geometry class. So from here, this is going to be a quadratic equation. I'm going to combine everything on the left side. Looks like I have 2x squareds and minus 6x plus 29. And then the right side, there's really nothing I can do in terms of simplifying. With every quadratic equation, you always want to get 0 on one side, everything else on the other. So I'm going to subtract x squared on both sides, makes life a little easier, and subtract 6x, and subtract 9. Okay, again, this is a quadratic equation. You all should be pretty comfortable solving these things. We reviewed them at the first day of class, I believe, way back in August. If you are shaky on quadratic equations, just remember, always try to factor first. If that doesn't work, then try quadratic formula. Here it looks like I can find two numbers that multiply to 20 and add to minus 12. Two such numbers could be x in here, negative 10 and negative 2. Because those add to minus 12, multiply to 20. So I get two possible answers. I get a 10 and I get a 2. So we always want to check if those work. If you do plug in a 10, you're going to get a triangle that looks like this. 5, 12, 13. Oh yeah, 5, 12, 13. That works. If you plug in a 2, you're going to get a 4, a 5, and a minus 3. Uh-oh, that's no good, because we're not supposed to have negative length. So this is going to boggle some minds, but just because we get positive answers doesn't mean that they're good answers. And also, when we get negative answers, that doesn't mean that they're bad answers. This one we're going to throw out because it does not produce acceptable measurements. This one will keep. Alright. So I'm going to stop here because I know this video is getting long and it takes a while to download or view. And I'll post one more with two last examples.